So let's look at part 5. It's given that the length of scoring line xy is actually 50 meters, so it's here. Okay, this is 50 meters. Then after which, find the range in which the optimal angle lies in, and the location of A varies between x and y, x and c. Now if this is 50 meters, and we know that these are P and P, so we know that this is 4. We know that A can range from 0, but of course not equals to 0 because because this is A, right? Point A can vary from here to C. So okay, let me just write that down because this is important. We need to form an inequality because we are asked to find the range which the optimal angle lies and the location of A varies, right? So from diagram, we know that A is 0 to XC. So since XY is 50, this would imply that XC is actually 50 minus 4 divided by 2, right? So just solve it geometrically. I think this is not like rocket science there, because this is 4, then this is 50. So 50 minus 4 divided by 2, that will be our range here. So this one, you key in calculator, I think it will give you 23, right? 50 minus 4 divided by 2, 23 meters. So we know that A is between 0 to 23, at most 23 meters, okay? Once you're done with that, once you're done already, we could actually use the optimal angle, because we find the range of optimal angle, right, which is this part here, tangent angle. So optimal angle is actually this, just divide by, so tangent inverse. So optimal angle, theta is just tangent inverse with 0, so that will be 2, you can use either one, so I'm going to use maybe this is easier, okay, 2 over tangent, maybe I just write this down, tangent of the optimal angle, tangent theta is equals to 2 over square root 4a plus a square, 4a plus a square, 4a plus a square. Okay, let me check. Okay, this is it. So in other words, optimal angle, so theta is just tangent inverse 2 over 4a plus a square. Now, I think it's better just use GC to just calculate the maximum, because you don't really know whether this is, you can't really tell at the glance whether this is absolutely increasing or decreasing, like strictly increasing or decreasing. So it's not going to be good to just simply deduce the max and the min based on the boundary condition here. So it's good if you can just key in calculator and know that your A is between 0 to 23, and then you just find what is the max and the min point. That's about it. So I would suggest doing that. But know what you're looking for, because now it's an angle. So angle is between 0 to pi over 4. So if there's a window setting, it'll be good if you are able to understand that. Yeah, I'm just going to plot this angle out. So tangent inverse 2 over 4a. So this is 2. Very good. 2 over square root. Sorry. It's tangent inverse 2 over square root 4a plus a square. Square root 4x plus x square. Okay, there you go. So this case here, what we're gonna get is essentially 4a plus a square. Is that right? Okay, great. So then I'm going to go window. Now make sure you know what you're adjusting, because now x is your a, which is from 0 to 23. So I'm going to put this as 0 to 23. 23, maybe put to 25. Okay. Maybe you could also put a domain here. Okay, so just put this 0 to 23. So this is 23 here. So then once you're done, you can just key this in, y min, y max. I'm going to put this as 0 to pi. I think it's more than enough. Pi. Okay. Then we can get this graph here. So you can see that this is a decreasing function. It goes to this value here. And then you can actually see, this is the function that you get. All right. Okay, what do we get at the end there? We will get, so this is a strictly decreasing function here. So the minimum point will be at this end here. So just trace, just put trace 23 at the maximum point there. This is 23. This is 0.0800856. Okay, so from GC, theta, the minimum point is 0.08008. 0.08008. Okay, so this is a strictly decreasing function here. Then at the maximum, can I equal to that? So this is equal to this portion 23. So this is equal to this. Then this 0. Okay, when it's 0, it's quite straightforward. 0, 0. This tends to infinity. Okay, it's actually, when this is 0, this is infinity. It's actually pi over 2. Okay, so you check. This is actually, as a goes to 0, 2 over 4a plus a squared goes to infinity. So hence, theta goes to, if it's infinity, it's pi over 2 definitely. So this is pi over 2 here. Okay. You can just check. I don't think you will get answer at when it's 2. It will be undefined. Let's just trace 0. Yeah, you don't get the answer there. So anyway, you can just deduce from here. That is how you do this question proficiently. If you have any questions at all, please let us know. Keep practicing, and I will see you in the next question then.